Welcome to our filter design. This is ME341 or experimental methods. It's fall 2023, December 6, 2023. My name is Mohammed Hussein.
My name's Hatakor.
So the problem statement, we need to design and implement a low pass filtering circuit using a RC circuit. We have four main constraints. Number one, it must remove the high frequency noise. Number two, the maximum allowable phase lag is theta over negative 20 degrees. Number three, our maximum allowable attenuation is 6%. And number four, the total cost of components must be less than $1.50. So our method is a product that relies on harmonic electrical input with frequency of 3.1 hertz and amplitude of 1.3 volts. And we'll use simulate to simulate RC circuits with various resistance and capacitance values. And we will run iterations to select resistance and capacitance values that meet design criteria.
So these are the equations that we used. Uh, we were given FF, which was 3.1 hertz, which we obtained from Simulink. Then we used that to calculate the cutoff frequency using the resistor and the capacitance, which which we had to choose. And from that equation, we were able to solve these two equations, uh, phase phase lag equation and attenuation equation.
All right. So our procedure is this is our first attempt. Our ohms is 1,000. Our frequency is 1 times 10 to the negative 6. Our hertz is 3.18 times 10 to the 2. And our magnitude ratio is 3.323 times 10 to the negative 7. And degrees is negative 0.009. So because this is our first design, it's unfiltered and it's pretty noisy, but this is a good way to start our procedure.
Next, we have the first uh, iteration that we did. We chose a 500 ohm resistor and a 100 or 1000 microfarad uh, capacitance, and the cutoff frequency was 6.37 hertz, uh, and the magnitude ratio was 3.23 to the negative 5, uh, and the phase lag was 0.45. Uh, all these criteria, all these criteria didn't meet the given criteria by the professor, so we had to do more iterations, such as this one. Um, this graph also didn't achieve the goal, so uh, then we did the third iteration, which was 100 ohms and 1 to the negative 3 farads, microfarads. And the cutoff frequency was 3.18, and the magnitude ratio was 3.23 to the negative 4, and the phase lag degree was 0.77. And as you can see, the phase lag degree does not uh, meet the criteria, so we had to keep trying. And this is the final design. This meets all the criteria as it filters out any of the high frequencies and only keeps the low frequencies attached. The resistance that we used was 1000 ohm, and the capacitance was 2.5 to the negative 6 farads, and the cutoff frequency was 1.27 to the or 127 hertz, and the magnitude ratio was 0.992, and the phase degree was greater than negative 20 degrees. And the cost for resistance was 10 cents, while the cost for capacitance was $1.11. And altogether, we were able to uh, meet the cost criteria as well, which was the cost of resistance and the capacitor has to be less than $1.50, and we were able to achieve that using this uh, capacitance and resistor.
So in conclusion, we learned to use Simulink efficiently and import pre-made circuit templates. We're able to modify components values for iterative testing, ensure accurate system designs. We explored real-world components on DigiKey and compared them based on design criteria. Our recommendations to browse DigiKey during system design for better component selection and run more Simulink iterations to optimize the design effectively.